Another question. If the radius of first orbit of helium ion is x, then de Broglie's wavelength of an electron in third orbit is about. So here the radius of the orbit in helium ion, we know that radius of nth orbit in any hydrogen-like species that is containing one electron outside the nucleus is given by n square a naught by z, where a naught is the radius of the first orbit, z is the atomic number. And also we have the de Broglie's equation. Lambda wavelength is equal to h by mv, Planck's constant by mass into velocity. And also we have from the postulates of Niels Bohr, mvr is equal to n into h by 2 pi. And this can also be written as nth orbit, mvrn, radius of nth orbit in general is given by n into h by 2 pi. So by using this, let us work out this question. So radius of the first orbit in helium ion is x. Since we are asked to find the de Broglie's wavelength of the electron in third orbit, let us first find radius of third orbit in helium ion. So R3 is equal to n square, that is 9, a naught, that is the radius of first orbit in hydrogen atom. So a naught is equal to radius of the first orbit in helium ion is given as x, and the orbit number n is equal to 3 we are taking, and helium ion z is equal to 2. So R3 from this relation becomes 9x and z is 2, 9x by 2. And we also have MVRN. In other words, MVR3 is equal to n into h by 2 pi, where n is third orbit into h by 2 pi. Right, R3 from this we have mv into 9 by 2 into x is equal to 3 into h by 2 pi, is it? So this is 3 times, and this is 2, this is 2. Thereby we have h by mv is equal to 3 pi x, h, bringing this mv part this side, h by mv is equal to 1 by pi, and here we have 3x. So h by mv being written as pi into 3x, that is 3 pi x. But what is this h by mv? That is, from here we have lambda. Therefore, the de Broglie's wavelength lambda is equal to, how much is coming out? 3 pi x. So do we have this lambda is equal to 3 pi x among the answers? So here is the D, which is the right option. So here we are using de Broglie's concept as well as radius of nth orbit for hydrogen like species. So here is the helium ion with one electron outside the nucleus, hence the concept can be applied.